In this proposition, we deal with continued proportions of non-constant ratios. We'll write these as a1 to a2 to a3 and so forth, where a to 1 to a2 is not proportional to a2 to a3, and same for in general. If the ratios are equal, then a1 to a2 to a3 is by definition a1 to a2 being proportional to a2 to a3. Again, in this proposition, the ratios are not equal. Given a set of n ratios, a1 to a2, a3 to a4, and so forth, to a to 2n minus 1 to a2n, all in least numbers, we'd like to try and find a continued proportion in least numbers that's built from these ratios. So we want x1 to x2 to so forth to xn plus 1, such that x1 to x2 is proportional to a1 to a2, x2 to x3 is proportional to a3 to a4, and so forth. First, let b2 be the least common multiple of a2 and a3. Then we can write b2 as m1 times a2, and let b1 equal m1a1, so that b1 to b2 is proportional to a1 to a2. We can also write b2 as m2 a3, and let b3 equal m2 a4, so that b2 to b3 is proportional to a3 to a4. We thus have two of the given ratios covered, with our continued proportion b1 to b2 to b3. We now need to cover our third given ratio. If a5 measures b3, so that b3 is equal to m3 a5, let b4 equal m3 a6, so that b3 to b4 is proportional to a5 to a6, and we have our continued proportion b1 to b2 to b3 to b4 that's built from the first three given ratios. Now the fourth given ratio. If a7 measures b4, so that b4 is equal to m4 a7, let b5 equal m4 a8, so that b4 to b5 is proportional to a7 to a8. If the a's keep happening to measure the b's by chance, then eventually we'll have a continued proportion, b1 to b2 and so forth to bn plus 1, that's built from the given ratios. We still need to show it's in least numbers, but we'll prove that later. For now, what if one of the a's didn't measure the b, say a7 does not measure b4? Then let c4 be the least common multiple of b4 and a7. Then write c4 as m4 b4. We need c3 to c4 to be proportional to a5 to a6, so let c3 equal m4 b3. Then c3 to c4 is proportional to b3 to b4, which is proportional to a3 to a4. We also want c2 to c3 to be proportional to a3 to a4, so let c2 equal m4 b2, so that c2 to c3 is proportional to b2 to b3, which is proportional to a3 to a4. Similarly, let c1 equal m4 b1. Furthermore, write c4 equaling m5 a7, and let c5 equal m5 a8, so that c4 to c5 is proportional to a7 to a8. We thus have a continued proportion c1 to c2 to c3 to c4 to c5 that's built from the first four of the given ratios. We now need the fifth ratio. If a9 measures c5 so that c5 is equal to m6 a9, let c6 equal m6 a10, so that c5 to c6 is proportional to a9 to a10. Like with the b proportionals, the rest of the a's might happen to measure the successive c's by chance till we're done. If not, somewhere, an a will not measure a c, say a11 not measuring c6. Like before, let d6 be the least common multiple of c6 and a11. We now need to balance all the previous proportions from C's into D's. Write D6 as M7 times C6, and multiplying the previous C's with M7 will perform that balance. Furthermore, write D6 as M8 times A11, and let D7 equal M8 times A12, so that D6 to D7 is proportional to A11 to A12. We thus have the continued proportion D1 to D2 to D3 to D4 to D5 to D6 to D7 that is built from the first 6 given ratios. Now that we have the whole process down, let's assume that we've done all of this and eventually found the full continued proportion built from the given ratios, say E1 to E2, and so forth to En plus 1. We now need to prove that this continued proportion is in least numbers. By way of contradiction, assume otherwise that instead f1 to f2 and so forth to fn plus 1 is in least numbers. f1 to f2 is proportional to a1 to a2, which is in least numbers. So a2 measures f2. f2 to f3 is proportional to a3 to a4, which is in least numbers. So a3 also measures f2. Thus, the least common multiple of a2 and a3, b2, will measure f2. b2 to b3 is proportional to a3 to a4, which is proportional to f2 to f3. So b2 to b3 is proportional to f2 to f3, so b3 measures f3. Similarly, b3 to b4 is proportional to a5 to a6, which is proportional to f3 to f4, so b3 to b4 is proportional to f3 to f4, so b4 measures f4. At this point, a7 does not measure b4, so we note that since f4 to f5 is proportional to a7 to a8, which is in least numbers, a7 measures f4, which means the least common multiple of b4 and a7, c4, will measure f4. c4 to c5 is proportional to a7 to a8, which is proportional to f4 to f5, so c5 measures f5. c5 to c6 is proportional to a9 to a10, which is proportional to f5 to f6, so c6 measures f6. At this point, a11 does not measure c6. So we note that since f6 to f7 is proportional to a11 to a12, which is in least numbers, a11 measures f6, which means the least common multiple of c6 and a11, d6, will measure f6. d6 to d7 is proportional to a11 to a12, which is proportional to f6 to f7, so d7 measures f7. Continuing in this manner, we'll eventually find that some E will measure some F, say En measuring Fn. But Fn is less than En, so we finally found our contradiction, and the proportions of E's are in fact in least numbers and fit the requirements we want.